Hi, everyone. I think we're ready to start the presentation. Welcome to the Trapeze webinar on revolutionizing public transport with next generation intelligent transport systems. My name is Ben Dvorak. I'm the general manager here in Australia that's responsible for rail across ANZ. Thank you, everyone, for joining us today. I think after a recent check, we actually have people joining us from Middle East, where it's extremely early in the day, and then obviously others joining us across Asia Pacific. So thank you very much for your time today. We'll be walking through a presentation to start, and then following the presentation, we'll have a live Q&A. During the presentation, feel free to submit your Q&A questions throughout. I'll be monitoring them throughout the presentation. Then following, we'll come back to answer some of those. And we've also included some complimentary ITS resources that are available for your leisure. You can take a look and you'll see those towards the left of your screen. So I wanted to start with a little bit of an introduction overview of Trapeze. For those of you who don't know, we're part of a parent company called Constellation Software that is totally focused on developing technology for niche industries. Now, under Constellation is a brand that was just actually introduced last week, and that brand is Modaxo. Modaxo brings together dozens of businesses across our portfolio that are focused on providing technologies that move the world's people. So all 12 of these businesses work together through Modaxo and then independently as well. And the business really is focused on one thing, and that is delivering technology solutions that connect people and places and people with each other. So as you can see, Trapeze is part of Modaxo. We've got about 2,000 employees and 40 offices around the world. We like to set up our offices as close to our customers as possible. Really, all of our people thrive on working with transport organizations to deliver dependable, integrated solutions across all modes. So you can see down there, we've got buses, taxis, ambulances, ferry, rail, and really providing that integrated experience, sharing insights from all departments across a transport authority. So the solutions we provide continue to grow with the transport industry through feedback that we receive from customers and partners around the world. So quick overview into some of the things that we're proud about. We've got hundreds of customers and transport authorities and operators working with us to develop technology and then working with us to utilize the technology to provide better services. And we've been doing this for about 50 years. So our presentation will speak to the various ITS deliveries that we've done. And one of the things that really touched me when I heard about it was our work with Zurich, Switzerland, where they've been using ITS for over 50 years. Now, I don't know if you've seen the box 50 years ago, but very different to what it looks like today. And by box, I mean the technology on the vehicle. But we've been working with them to sustainably keep that technology up to date. And they're using the latest and greatest today and what are the most advanced users to provide that integrated experience to their riders within Zurich. Now, everybody's aware of Transport for London, a world leader in transport technology, also utilizing the ITS solution to manage 7 operators, all delivering that integrated experience to 8 million passengers in the City of London. Now, as you can see, we're involved in multiple modes. As I mentioned, our solutions actually work to support the delivery of services into rail. We've also got the largest taxi fleet utilizing our in-vehicle technology in Dubai. And for those of you that have been to Dubai, taxi is an integral part of how people move. Very, very hot environment. I'm extremely proud to be involved there with the RTA. And then supporting autonomous buses. So there's a lot of discussions now about electric buses, about autonomous buses. David will speak to some of those, but we've been working closely with transport authorities to support that integration of a new autonomous bus into fleets. And then really, I think, mobility as a service, there's all sorts of definitions and different levels of maturity in mobility as a service. And we've been working with Denmark to integrate all modes of transport, across Denmark, across 4 different authorities. I think majority of that work sits with those involved at the political level, but supporting from a technology perspective to allow that integration to happen. So all of these transport authorities that work with us, the industry groups that work with us, they challenge us every single year to further innovation. So they challenge us to get more out of their technology. We build that into our technology and provide that out to other customers and transport authorities around the world. So introducing our speaker. David's an interesting fellow. He's been doing this for a long time. He has a great understanding of intelligent transport systems and how they've evolved over the past 20 years and likely before that, as he is quite studious in the subject. You can see David's completed his studies in engineering and has his MBA. He's also delivered ITS training in places across Asia Pacific, like Hong Kong, Malaysia, all across Australia. David's passion is to support transport authorities and operators in achieving their goals and securing a sustainable future with world-leading technology. He's also presented at many events and written numerous papers, including contributing to the book Transport Innovation, A New Era for Australia. But there's more to David than meets the eye. Apart from keeping across technology developments, he also likes being a trendsetter. So you might not see it when David opens his screen up, but he's, he sets goals, and one of the interesting goals is learning how to ollie. And if you don't know what an ollie is, it's a skateboarding trip where you don't use a ramp, you just kind of hop on a skateboard. You don't use your ramp or your hands. I've never been able to do it myself. And so he's mastered that, and now he's taken to the water, and he's learning how to kite surf. So for those of you that are familiar with kite surfing and know the local spots, especially here around Brisbane, you might see David kite surfing and practicing his skills there. So I will hand over to David, who will show his camera there shortly, and we'll go through David's presentation, following which we will move into Q&A.
Well, thanks, Ben, and good afternoon, everybody, and thanks for your time today. Now, our plan today is to have a quick look at the current state of ITS, see where you sit on the innovation curve, and then discuss some public transport revolutions. We'll then focus on AI and electric vehicles and wrap up with a discussion on the benefits of pre-positioning your organisation for tomorrow's technology. ITS in public transport is recognised as the automatic location and control of public transport vehicles and the delivery of real-time information to passengers using those vehicles. Now, this has significantly evolved over the past 50 years. However, it's in the last 20 that the ubiquity of high-speed data networks, GPS, and cheap computing has opened up the floodgates on transport innovation. Public transport leaders have been innovating and pushing the boundaries with ITS solutions and have been able to use them to great effect. Let's get this. In London, Transport for London, they've empowered their operators, and then they've monitored their performance and deriving payments and penalties from these metrics. In Singapore, historically, there were only 2 commercial bus operators with little to no visibility of their performance. After the LTA implemented the Trapeze ITS system, well, they were then able to successfully open up this duopoly to new operators and deliver the public transport services that passengers wanted. Now, as we know, Singapore is actively controlling their vehicle numbers. So an effective public transport service helps the LTA offset the demand for cars. Success for ZVV in Zurich meant that they were able to manage their tram, bus, and trolley bus operations as a fully integrated solution. They've steadily improved their incident management and maintained daily operations in a heritage city, even when it's deep in snow. Now, the cutting edge of intelligent transport systems is an exciting place to be. Innovation abounds, with autonomous buses, artificial intelligence, and facial recognition all in the ascent. For some transport agencies, these technologies are an excellent way to showcase their own innovation. They accept the financial and technological risks of being first, and they know that by doing so, they can steer the technology where they want it to go. And it improves the overall service delivery to their customers. So these are known as the innovators in Rogers' diffusion of technology graph. This graph plots the various types of users of the technology against time. One of the things that can be seen on this graph is that you don't have to be an innovator to take advantage of these technologies. Everyone can benefit. It's only a matter of when. As an operator, you may choose to pioneer with innovations and new practices. Whilst that means that you shoulder all of the risk and the effort in getting the technology working, when you get it right, your customers will be very satisfied and you have a substantial market lead. You may also choose to be an early adopter, following the innovators and selecting technologies as they're proven. For instance, in London, low bridges are an issue for double-decker buses. Now, London has worked with Trapeze on ITS innovation so that their drivers are now warned when they're approaching a low bridge. Singapore does the same sort of thing for their double-decker buses in relation to low trees. Those that don't have this innovation, well, they're still open to disasters. With the issues worked through by the innovators, as an early adopter, you know that technology is ready for your use. And you can choose to implement it when you're ready. Regardless if you're an innovator or an early adopter, you can pre-position yourself for success for getting the right technology platforms in place now. IDS systems make great use of existing technology. By working with the leading transport agencies, vendors like Trapeze have ensured that they can also support cutting-edge technology, such as autonomous vehicles, electric vehicles, IT for PT, and artificial intelligence. At times, though, innovation is driven by necessity. In 2016, there was a major tram accident in London. Sadly, 7 people died. 19 were seriously injured. The cause was determined to be driver error, resulting in high speed. So after the event, Trapeze worked with TfL on helping to solve this problem. Now we monitor the speed on the London trams on their ITS system. This speed automatically feeds into the dispatcher alerting system. That prompts a manual intervention and increases safety. So what's driving ITS overall? Well, it was the Industrial Revolution that gave us cheap iron, spinning jenny, dynamite, and the telegraph, changing the world. Interestingly, dynamite and gelignite were both invented by Alfred Nobel, who went on to create the Nobel Peace Prize. Arguably, the biggest driver of advancement was the steam engine, which transformed public transport through the invention of locomotives, steamships, and motorised buses. Information technology is driving the next transport revolution. As was the case in the Industrial Revolution, however, this is not a solo effort. With advancements in financing, route contestability, and electric vehicles all making valuable contributions. And social expectations are also involved. For instance, the expectation we look after our environment, and the greenhouse gases in particular are a major environmental issue. They're driving the take-up of electric vehicles. The case for change is clear. The governments are starting to address this, with 66 countries announcing a net zero emission target by 2050. Some are even talking about by 2030. Battery electric buses and hydrogen fuel buses are widely seen as a major way of achieving these goals. The zero-emission vehicles seem to be straightforward enough. You combine batteries with electric motors, away you go. Yet there remain issues over range, recharging and financing. The industry has resolved many of these issues with lighter vehicles, better batteries, and a range of charging stations. Vehicle ranges around 180 to 200 kilometres per day, and the expectations are getting up around 250 to 300 kilometres. Governments have recognised that the CapEx, OpEx dilemma, they've recognised that, and funding for vehicles is being modified, and they're working on alternative financing structures. Now, ITS is being used to plan and support the operations based on the more constrained range of electric vehicles, where it factors that it has to factor in the need to change the batteries at selected waypoints, deals with the mixed fleet as operators transition out of the old diesel vehicles. At Trapeze, we partner with specialist applications to manage the slow charging vehicles within the depot, and our ITS solution shows the state of charge, the running time, and the range of the vehicle in the control room, all in real time. So if batteries are getting low, automatic alerts are generated, and that allows preemptive opportunity charging or even vehicle swap-outs to be initiated. Now, this is important because electric vehicles are a major way to increase passenger satisfaction ratings. Not only are they clean and green, but they're quiet, and with properly trained drivers, they're smooth. So Elizabeth Mildwater put it very succinctly, and she said, customers like zero-emission buses. By having an ITS that's able to support, it's already able to support electric vehicles, then you're getting ready for direct improvements in customer satisfaction. Increasingly, the benefits are also available in less obvious areas. So in Shenzhen, where they moved their entire fleet of 6,000 vehicles to electric buses, right, as innovators, they gained the expected benefits of lower running costs and higher availability. They also identified reduced complaints around depots due to the lower noise level. And one of the biggest uses of IT in today's world is that of artificial intelligence. AI underpins recent developments, such as personalised trip planning. Now, in Switzerland, the SBB Smartway app uses AI to look at your regular travel patterns. And if there's a disruption of services that might affect you, it pushes you a notification so that you know about it before you even leave the house. The app shows you the transport modes available and the best connections for tram, train, trolley and bus. And it does all of this in real time. These apps have been very well received, and they go a long way to improving customer satisfaction. With COVID, some of these apps, of course, have been updated to reflect load factors so that they can give customers the option of the next vehicle that's perhaps a bit less crowded. We're using AI to look at the way that parts are used on vehicles. It's possible to change preventative maintenance into predictive maintenance and invoke services just ahead of the failure curve. Asset condition monitoring is a key part of our ERM software and can dramatically reduce servicing and part holding costs. Other general uses for machine vision can include face mask detection, such as in cans, where it's being used to determine the level of compliance to mandatory mask wearing, or incident detection on autonomous vehicles. For instance, in the autonomous vehicle, there won't be any staff. So an AI solution can detect an elderly passenger's fall and then automatically trigger an emergency call. Or in ticketing, where facial recognition is being used for a ticket sale, used to drive a ticket sale. It's already being used on high-speed trains. It's now under trial in the Shenzhen metro in China. Machine vision has also been used to enhance passenger and station safety. And this ranges from identifying abandoned luggage in railway stations and airports to identifying potential suicide and enabling earlier intervention. Transport for London are running a trial with their operator Abellio London using AI and machine vision to preemptively detect and avoid collisions. Our results are showing that it's reduced avoidable collisions by 29% and it's reduced onboard injuries by 60%. In Singapore, they're trying to go further by taking historical data from a bus driver's work records, telematics data produced by each bus, and observations made by the onboard data scientists to feed an AI system to determine whether a driver is likely to cause an accident in the next 3 months. Then intervention in the form of additional training may avoid the costly and potential life-threatening accident. Sound like Minority Report? Hang on. Autonomous vehicles are demanding attention, if only for the fact that they're yet to deliver on the promise. However, this month's move to fully automate the operation of Waymo vehicles in Phoenix, Arizona, is showing the steady progress of the automobile market. We already have electric buses autonomously moving around depots to get cleaned, charged, and parked. There are also real-world operations, such as the Trapeze partnership with the Schaffhausen Transport Authority, where the autonomous shuttle named Trapeze, which you can just see in the picture here, has been integrated with conventional route buses by the Trapeze ITS system. The fast pace of the transport technology revolution allows advanced technologies from other industries to be quickly incorporated into the existing technology. Now, historically, a good example of that would be mobile phone technology, which opened the floodgates to real-time data flows and lower costs, delivering location and ticketing data, and that in turn made real-time predictions viable. If you're an innovator, you'll want to be aware of what's on the horizon. You'll be looking for a partner to help you get the most out of these new technologies quickly. If you're an early adopter, then you'll also want to know about the technologies, but we'll want to see how they're used by innovators and how you can get some of these benefits without the risk. In each case, you need a platform that can support not only the existing technologies, but one that has a proven history of being able to move forward with you at a pace that you're happy with. So let's look at Headway, for example. Passengers are demanding higher levels of service with regular high-frequency services. Modern Headway management systems can deliver this, leveraging off the existing tracking technologies as well as new mobile devices and control systems. Implemented in London and Singapore, and soon in Sydney, Headway management is emerging as the preferred method to manage high-frequency services. TfL is on the leading edge of this technology. Together with Trapeze, they've helped define the measuring standards, the operating processes, and the payment mechanisms. Many technological options were rejected en route. This is pretty normal for innovation. Early adopters can now take up this technology without going down these dead ends. So with Headway management starting to enter the mainstream, transport authorities are now requiring this as part of the new operating contracts. Technology has evolved to the point where Headway is a standard component of existing ITS solution systems. It's now possible to get bidirectional Headway control via mobile phones and tablets that operate alongside existing ITS solutions, blending the full power of ITS and low-cost mobile devices into a single back-end. The innovators have done their work, and early adopters can take advantage of these developments now and with an advanced ITS system and one of its Headway services. Automatically calculates their waiting time, and depending on the hardware selection, can deliver just Headway or deliver a full suite of vehicle control, passenger information, passenger counting, security, and Headway. I'm in a bit of trouble with my slides moving around here, so bear with me. So worldwide, the trend to outsource operating contracts for public transport is getting stronger. This requires technology that monitors what services will run and derives automatic performance metrics for payments. These capabilities are available right now to all operators and agencies for modern ITS systems. Underpinning these outsourced contracts, some authorities have invested in a performance management system that collects the performance data whilst at the same time delivers the operators a mechanism to allow them to deliver a quality transport system to the city. We're seeing this in both London and Singapore, where they recognise that the authority needs data. And if they want the operators to improve, then the operators need to be able to control their fleet. So for instance, London wanted to headway manage a large proportion of their routes. The Trapeze ITS solution allowed Transport for London to monitor the operator's performance and, by using the same system, to empower the operators so that they are able to maintain this performance even as the average road speed dropped from 18 down to 14 miles per hour. Because bus and tram ITS systems are delivering more efficient operations by providing real-time visibility of the fleet's performance and a means to actively help drivers deal with these disruptions, they're fundamentally changing the way that companies operate services. So, what's the best way to be part of this revolution? There's been a lot of discussion over the years on if it's better to be an innovator or an early adopter. Innovators require vision, money, and a culture that accepts that some paths are dead ends. The newest technologies are, by definition, innovative, but they're also immature. And working out how to use them takes time and experience. There are also financial considerations at play. For example, electric vehicles are on the cusp of widespread availability. But even with a full understanding of how you're going to use these vehicles, the full replacement of fleet has a large capital outlay and maybe 10 to 15 years away. Innovation is typically a team effort. And Trapeze works with innovators all the time to develop ITS technologies, blending our experience with our customers' drive and vision. Now, if you're an early adopter, you don't get the long lead time and the publicity of the innovators. But by following closely behind, there is still opportunity to deliver great services to your passengers or to differentiate yourself from the competitors. Now, importantly, for commercial operators, there's still plenty of opportunity to reap the financial rewards of higher efficiencies and lower costs. Early adopters can pre-position themselves by looking at areas such as an ITS system, which has matured and supports a mixed fleet of traditional vehicles as well as future autonomous and electric vehicles. This lets operators manage their current assets in a low-risk approach, whilst allowing for the incorporation of new technologies as and when required. ITS systems can deliver control and performance benefits immediately, and by being technology ready, will support you well into the future. Technology leaders are like icebreakers. They carve a path from A to B, leaving a clear channel behind. As a transport operator, you might prefer to be less like an icebreaker and more like a passenger ship. As long as you're happy with the direction taken, you can safely follow immediately behind, give your passengers a trip that will truly delight them. Even then, it's possible to make mistakes. Czech Republic has highlighted that an early adopter strategy needs to be just that, a strategy. Not having a strategy could mean you're following too far behind. And the Harvard Business Review backs this up by highlighting that often by the time companies find a strategic imperative to respond, it's all too late. There's also the risk that you're following the wrong technology crowd off a cliff rather than towards the future. You may fail to learn from the mistakes of the leaders, repeating their errors whilst they move on to far greener pastures. But whilst these are real risks, they're manageable, and working with the right partners can help mitigate them. Early innovator or early adopter, the PEs can be your pilot, guiding and assisting you towards your destination, avoiding problems and potential dead ends. Like the steam engine, information technology is enabling radical change in public transport operations. There's no doubt that we will see autonomous vehicles and electric vehicles in our fleets. They'll operate with more flexibility, but beneath the surface, the supporting tools allow operators to deliver these services at a lower cost to more people. Many leading agencies have chosen to be innovators, and we're working with these innovators to build a strong ITS base to drive and extract value from the emerging technologies in new and exciting ways. We continue to look to innovate and are looking forward to delivering the next wave of ITS innovations that support electrification, autonomy, and more. We believe these innovations resonate globally and that they're available for a global network of public transport companies now. By working with the early adopters, we've helped them select winning technologies proven by others. In doing so, they can delight their customers with modern services at lower costs for a long time. Regardless of your choice, by leveraging Trapeze technologies and experience, all public transport organisations can participate in the new public transport revolution. Ben. We're open for questions, Ben.
All right. Thank you, David. Really interesting presentation, especially with some of the new developments and in ITS and artificial intelligence, especially how it's now supporting the safety of transport users around cities. So, you know, obviously with the population increases and the needs and driving people to transport for both green purposes and sustainability purposes, safety will become even more of an issue, right? Obviously, we're in a pretty delicate environment now as well. So thank you, David. Now we'll move over to Q&A. We've had a bunch of questions come in, and appreciate everybody for utilizing the Q&A function there. So let me just move the screen over. Apologies. So first one here. How does ITS work with multimodal transport? So for example, integration between buses, trams, and ferries, and utilize London as an example there in your presentation, David.
Okay. So basically London uses the same system to manage all of these modes. And that, because they're using the one system to manage bus and tram and ferry, they're able to deliver a consistent view of all of those services and a consistent view both to the public and to Transport for London in their operational reporting. So in other places like, say, Zurich, the passenger information there across the modes extends right into the vehicle. So when a tram approaches the train station, the passenger information screens inside the tram can then put up the train departure times and the platform numbers for the train, so that passengers on board the trams can know exactly where to go and whether they've got to run or whether they can go and get a cup of coffee on the way. Does that cover it?
Yeah, I think so, David. And it's interesting with London because they have so many different operators that are supporting the delivery of these different transport modes and you know, so many different lines and routes. But you know, when you ride Transport for London service, you never know when you're on one operator and another, and they're all competing companies, right? But working towards the same goal. So it's really, yeah, it's a great service there. So another question here, how does ITS alert drivers now when it comes to low bridges?
Yeah, so what happens here is that when we lay out the data for the routes, we can define where these particular points of low bridges are, or trees if it was in Singapore. And when the vehicle starts to approach that point, then an alarm goes off inside the cab for the driver. So he actually hears the alarm, she hears the alarm, and then they know not to go down there. And the range at which that threshold can be set is configurable. So you can set it up to be just at the end of the street or just before the individual bridge, depending on the seriousness of the event and where you can actually turn to not go down there. So if you're in a bus and you turn a corner and the next thing you're going to spot is the bridge, then the alarm will go off as soon as you turn you can set up so the alarm will go off as soon as you turn the corner, because you shouldn't be on that street. Right? And then hopefully the driver will look up and remember he's got a double-decker bus and not a single-decker bus.
Thanks, David. Yeah, that's another interesting one, right? Being a new driver, having an ITS system, I would want to know that the bus will scream at me when I'm going down the wrong path. You know, being passenger, I always feel pretty safe on the vehicle, with all these things happening in the background to ensure that happens. And yeah, thanks for that. Okay.
Yeah, well, it's interesting that in buses and the ITS system, the off-route system will tell the bus driver that he's gone off-route anyway, but this is an extra, where we're actually saying if you go off-road, it's dangerous. There is a bridge there that's going to cause damage, so don't do it. So you wouldn't normally get a screaming alert if you've just gone off-route, but you will if there's a damage point ahead.
All right, another one here. You know, a lot of talk about headway, and this question centers around headway. So how does headway management help the operators, and how is it measured?
Yep. So headway is primarily aimed at making life for passengers easier, less stressful, so that you can show up on a high frequency service. You would just basically show up at the stop without having to check the timetable and say, oh, the bus is due. You know, you just show up, and if you have confidence that the bus is going to show up within the defined time, and not show up as after, say, 20 minutes and then be followed by 2 or 3 other buses. If you've got confidence that every 5 minutes there'll be a bus, that's a very good system to have, and you would just roll up at the bus stop on a whim. You won't even check the timetables. So headway is all about each bus driver being told when he's at the stop how far ahead the other bus is in terms of time. And then he can say, well, if I'm running to a 5-minute headway and I'm currently at 3 minutes, I'm too close. So I might then just take my time driving out. When I pull out from the bus stop, I won't pull out like Mad Max. I'll pull out very cautiously. I'll let a few more vehicles pass, and I'll burn a few seconds to help spread the distance so that I'm going to be 5 minutes away from the bus in front. So they do that. And in some places, because no one really wants to sit there and wait for 20 minutes when there's a 5-minute service and then have 3 buses arrive. That's just, it's not good from anyone's perspective, because the first bus is packed to the gills and the next 2 buses are going to be empty. And you will catch the first bus because you just waited 20 minutes for it to come. So they have in the ITS system in Singapore, they actually have an alert, which is a 3-bus bunching alert. So if the system detects that there are 3 buses bunching up, it will alert the control room that these buses are bunching, and then they can do something about it from there. I guess one of the things about headway is that when you're doing it, you can monitor and measure it. It's a measurable thing. You know, if we've got that 5-minute service and a passenger knows it's 5 minutes, then on average they're going to wait about 2.5 minutes if they just show up. So if the service extends out to 6 minutes, right, then on average they're going to wait 3 minutes. And that extra 30 seconds is excess waiting time that the passenger wouldn't normally have to wait. And that's what we measure. And It's the extra time that the passengers wait. And we can measure that, and we do it on a per bus basis. We can report on it by a route or by time of day or by month. When you average all of these numbers out across the whole route for a month, you get a measurable number, which you can then say, that's how we're performing. And, we're okay with that, that's good, or we want to drive a performance and using financial incentives to drive it down, which is pretty much what London does.
Yeah, I take a bus to work every day. It used to be rail until I moved, and now there's the city hopper here. And yeah, it's, putting my passenger hat on, always appreciate a bus with less passengers on it. Once in a while, you do get the two buses that show up right beside each other. But, understanding that technology just helps create these efficiencies, right? Obviously, then it could potentially overburden the buses behind it, right? So definitely important. What else do we have here? So I guess, David, just for my own, maybe for the people on the call that are on the tram side, rail oftentimes does have headways, but isn't competing with traffic. Would you see this headway being discussed now in tram environments?
Oh, absolutely. It's definitely applicable to trams for exactly the same reason. You're running a high frequency level of trams. They've got bigger capacity. They certainly have some limitations as to where they are if they're mixing it with traffic. But if you can have the drivers and modify their travel speed to maintain that headway, exactly the same parameters apply, and the quality of service for passengers is all the better.
Okay. So how can cities use ITS to deliver quality based on services to the public?
Well, I guess there's a couple of things that probably come out of this. In some cities where basically the transport is funded by the public and the operators are run on a commercial basis, then in that scenario, ITS can give information out, they can be passengers informed, and they can help the operators deliver on the service. But where the city is collecting the revenue, then the system can report on that performance of the service so that the city knows that it's spending its money wisely. It's getting the value for money because it's contracted out services. So there we basically be looking at seeing how companies are performing against their contractual requirements, and we can measure things like, we can measure headway from, but we can also measure service compliance, and we can measure when the first service was run and when the last service was run, and were those tail end services run or were they shortcut, or whether there were disruptions and diversions and how many of those were put in place and how long they were. And so all of that information can be measured, it can be captured. We can even capture in it reasons for performance. So if there is a reason for a particular disruption, then the operator could, in the right system, could just enter into the system that we didn't have any control over this. There was a big event in the city. There might have been a terrorist event, and therefore we couldn't go in. And then the authority is in a position where they can say, understood, not an issue, and I'm not going to penalise you for that. Whereas if they just go, well, the driver wanted to get home early, so he turned short, and then that probably doesn't cut it.
Yeah, and I really like the part of that question where it's based services to the public, because oftentimes, we understand there's a return on operators and authorities using this technology to do, meet their KPIs, create efficiencies in a variety of areas, and also respond to events dynamically and proactively, right? Sort of start putting those plans in place. But, the end result is providing better service to the public. So at the end of the day, it's the customer that's benefiting as well, which is the important part as well. So we've got a good question here as well. So this one just came in recently. And so can the ITS system support network optimization, utilizing automated historical data to improve future planning. So there's a second part and I guess a focus area, and especially when drivers try to wait at bus stops to meet timing points.
So the answer to that is yes. There's two components that come into this. The first one is that you have to be able to determine when you're going to arrive and how long you want to wait for that. But if you're optimizing the timings, then that typically is done in the planning stage, but the ITS planning can be made very, very sophisticated. There's already a lot of sophistication in the planning that takes into account a lot of historical data, and that includes average travel times and that sort of stuff. There's a lot of work going on now using AI to delve into that, go further, and factor in. And I know Trapeze, we're doing a bit of investigation into this sort of stuff, where we can basically factor in other events like major city events, weather, traffic flows, and you fold all of that into the algorithms, and then you come up with predictions to what things are going to be like based on those parameters. So if it's going to be raining tomorrow, then maybe the travel times will be different and the arrival times will be different. So the second part of that question was related to
when the driver waits at the bus stop to meet timing points. So I think there's, looking historically, when a driver has at these timing points waited a little bit longer than anticipated, can that then be fed back into the planning process to improve the plan to make it more realistic, deliverable?
So there's a couple of things there. If the drivers are consistently waiting at the bus stop, then obviously that would be, it's more unrelated to the drivers and more related to the bus stop, and that can be definitely fed back from, it's identified within the ITS solution, then fed back into the planning solution. That could also be tied back to the individual drivers, so that you could say, well, this particular driver is spending too long getting out of that particular stop. And maybe there's a local cafeteria nearby, and then the layover point, and he was picking up a few extra donuts. And that's a regular thing. But the ITS system on its own won't cater for that, but it can identify it so that you can go and have a chat with your driver about the need for more physical exercise and getting out on time. So you get the layouts. Typically what happens in layovers is that we tell drivers when they're supposed to leave. So the system will have on a display, it'll just say, here's a countdown. You've got 5 minutes, 4 minutes, 2 minutes time to leave. And that helps get the drivers away on their scheduled time. And then the scheduled time is what underpins everything. So if they then haven't finished the layover, get away on the scheduled time, the ITS is helping you drive a better service. And that's fully automatic, no matter what was planned.
Yeah, and I think it's the important piece is that historical data. So all of the systems really consume all of this data, and then how do we then utilize it to improve future services, right? So it's definitely something that we're constantly working on, and it's over data and then actually having that as useful information to action. So definitely where the software supports as well. Yeah.
Ben, we're doing a bit of work at the moment in Trapeze, looking at the use of AI and working with one of the leading English universities to work through AI and just not only do that historical thing and do the predictions better as to when vehicles are going to arrive at a stop, and that's currently around about 98% for here and now announcement predictions, but also looking at AI to look at how to do an intervention. So this is not in our system yet. We're still in investigation, but having identified that there was a problem, the AI can come up with several alternatives, ways of solving that. You can reroute your buses and send a diversion automatically, or you might inject another vehicle, or you might just do nothing and wait, depending on what those solutions are. And so we're looking at all of those options and then presenting a selection of those options to the operators to actually make use of that. So that's moving into the next stage. It's taking it from just being a reporting tool into being a useful partner in managing the services.
All right. Yeah, I guess it's it's really interesting when we talk to transport authorities. There's so much investment that goes into the assets, the infrastructure, maintaining them, and technology can really help get the most out of those assets. Right, make sure that they're deployed efficiently, and make sure that the public is getting the best possible service out of all that time and effort that is spent planning and delivering that service. So. All right, I think that's all we have time for today. David, appreciate you pulling this together. To everybody that has joined the call, really appreciate you setting time aside through your day. For those of you that will be watching this on your own time, thank you for watching. I'd like to kind of close this off by saying you should check out our ITS Hub, where David and the global team will continue to add new papers, new blogs, new insights. We're constantly talking to transport authorities about what they're looking to do next and how they're utilizing their current technology through both uncertain times, but also planning for the future and learning from the past. So we're posting that. David's currently working on a new white paper. I think David's always currently working on a new white paper, and but this most current one will be released next month, and it'll dive deeper into ITS with some real world examples of how it's being used. So thank you all, and enjoy your day.